by the balance of the Wheatstone bridge, or in other words, a resistance bridge, we understand the situation when in such a circuit connected to a current source through an ammeter or more often through a galvanometer, the current stops flowing. Let's now understand when the condition of this very balance arises. That means that we will obtain a formula showing at what ratio of resistances in the circuit the current through the ammeter stops flowing or becomes equal to zero. To do that, we need to draw an equivalent circuit. And the point is, since the current doesn't flow through the ammeter, that it can simply be thrown out of this circuit. This will change nothing. But then it turns out that resistors R1 and R2 are connected in series in this circuit, as well as resistors R3 and R4, as shown in this circuit. Well, then at the top of this circuit, we have the current I with index B, and it is the same for resistors R1 and R2. Similarly, at the bottom of this circuit, the current I with index H flows through resistors R3 and R4 connected in series. On the other hand, since there is no current flowing at the place where the ammeter is, these points can be connected with a short circuit, a thin short wire with near zero resistance. And again, this will not change anything. Nothing bad will happen in this case, since no current will flow through this short circuit. But this simply means that resistors R1 and R3 are connected in parallel, as well as resistors R2 and R4, also in parallel, and both resulting cascades are connected in series with each other. This means that the equivalent circuit can also be like this. Well, then, since resistors R1 and R3 are connected in parallel, the voltages on them are the same, so we get the following equation. A similar condition is true for the second cascade with resistors R2 and R4 connected in parallel. This means that this equation also takes place. And all we have to do now is to simply divide the first equation by the second, and we automatically get that very balanced condition of the Wheatstone bridge. Or sometimes it's written down like this. Here is the answer. And in my opinion, this is a rather interesting and simple proof. That's all for today. Thank you for watching and for your donations.